you will have seen the Earth's moon shining in the sky. You might think it's just a plain grey ball of rock, but there's more to it than that. If we use a telescope to have a better look at our closest neighbour in space, we see many different features on its surface. Hundreds of years ago, people thought these large dark areas on the moon were filled with water, like the oceans on Earth. We now know that these huge flat plains are made of basalt rock. We find the same kind of rock on our planet. Because they were once thought to be oceans, these dark areas were called maria. Maria is the Latin word for seas. We still call them maria today. You may have heard of the mare that is also known as the Sea of Tranquility. This is where the Apollo 11 mission landed in 1969.
That's one small step for man, one giant leap for mankind.
Neil Armstrong and Buzz Aldrin became the first people to step foot on the moon. The maria are billions of years old. Large asteroids hit the moon and cracked the surface. Liquid rock rose up through the cracks. Lava flowed out on the surface and cooled to make the maria. About 1/6 of the moon's surface is covered by maria, and most are on the near side of the moon. This is the side that always faces Earth. Scientists think that the far side contains fewer maria because the rock there was thicker. This meant impacts by asteroids could not break through the rock and release the lava underneath. The lighter, brighter areas of the moon are covered in mountains. These are the remains of the rims of huge impact craters. Some are 3 or 4 kilometers high. The rock in the mountains is much older than in the maria. The fresh lava that flowed out of the cracks did not reach as high as these tall mountainous peaks. If you look closely, you notice chains of mountains. The last 2 mountains in this chain make a valley. This is where the Apollo 15 mission landed. You have probably noticed that the moon is covered in round features. These are craters. These were made by pieces of asteroid hitting the moon. Craters are round or oval. A tall crater wall surrounds the smooth, flat crater floor. Often there are bright streaks around the crater. These are called ejecta. This is the rock that splashed out during the super hot impact event. Large craters like Tycho have a high point in their center. During the impact that made the crater, a wave of molten rock flowed back towards the middle and then cooled and hardened into a peak. The largest craters are called impact basins. The moon's South Pole Aitken Basin is 2,500 kilometers across. That's nearly a quarter the size of the moon. The walls of these immense craters form mountains up to 8 kilometers tall. That's as high as the tallest mountain on Earth, Mount Everest. Some craters on the moon are more than 2 billion years old. The moon does not have an atmosphere or weather, so craters are not covered or worn away over time. The oldest craters are in the mountainous areas. There are fewer craters in the maria because they've been covered by lava flows. There are more craters on the far side of the moon than on the near side. This may be because it contains fewer maria. It may also be because the Earth has acted as a shield and stopped asteroids from hitting the near side of the moon. The surface of the moon is covered in a mix of dust and very small pieces of rock called regolith. Regolith means blanket of rock in Greek. The fine powdery top layer of the regolith is called the lunar soil. On Earth, the regolith and soil are made by weathering. This is where water, weather, acids, plants or animals break down rocks and minerals into small pieces. On the moon, there is no weather or life. The powdery regolith has been ground up over time by meteorite impacts and solar wind from the sun. Because there is no weather on the moon, the footprints left by the Apollo astronauts are still there today. Scientists have used telescopes, astronauts, and robots to learn about the moon's surface. As we continue to study the moon, our knowledge will grow, and this knowledge helps us understand other rocky worlds, including our own planet, Earth.